What is cooking good looking? So this is Lab 6 servo motors. First I am going to show you unplugged. We have servo motor here. I used red for 5 volts, black for ground. The orange wire is going from the Arduino to this. We have an additional yellow wire, which is the output from the potentiometer back to the Arduino. If this is not proper instructions, for example, I don't own a brown wire, I've explained here. In the lab, there are 2 separate wiring colors, so I chose the one in the description. And so if we look at this, we have 5 volts coming from the Arduino to the 5 volts column that's running through the whole thing. This is a smaller servo motor, so therefore it doesn't need an external battery. It's like a micro one. Whatever. We have 5 volts going into the potentiometer, ground connected, the output there giving us values of 0 to 1 2023. Those are adjusted. We have 5 volts and ground plugged into the servo, and we have the pulse width modulation time barricading through that orange wire there. So if I plug this guy, hey, plug in, hey, come on. Is it this one? Here? Okay. So you can see I go from there all the way to 180 degrees there. Through the twist of a simple little knob. Oh, how whimsical. Oh, the whimsy. So if we go over here, looking at the code, I'm going to re-upload it so we can look at the serial monitor. Press serial monitor. We have 3 outputs. First is 20,000, which is the control time for this. I did not have problems with the T-sub control for this lab, so that was not adjusted. Then we have the length of the pulse width modulation printed. Then we have the angle. In this case, it is all the way down, so we have an angle of, negative 89.82. Beautiful, fine, and dandy too. Okay. So then if I turn on auto scroll one more time, right, and I twist it the complete other direction, see it's all the way over there, and I turn our beautiful little friend auto scroll off, we now have 90 degrees, 2,500, which is a little over for it, and 20,000. So in the data sheet, I pulled all these values from a data sheet I found online for my motor. Futaba, not Futaba, that's the lab. This is whatever company, a company, right? But note the striking similarities here. Striking, reach out and hit you. You can see it notes 1 to 2 milliseconds. I had to adjust those, and a 20,000 microsecond cycle. If I scroll all the way down, you can see here they even include a handy dandy little diagram. If we go back to the code, I'll just take a fine and dandy moment to explain what's going on here in the final minute. So we set up the output and input ports. Following that, we read from A0, the analog input. We adjust that reading to the time we want. Now, we have a term, A plus 1, to turn it from 1 to 1024, divided by 1024 is a ratio. I adjusted the 0.7 and 1.8 to get the the full range of motion I wanted, and then multiplied by that by 1000 to convert to microseconds, given we use delay microseconds. Then I printed that. I used digital write 7 high, delayed that time, digital write 7 low. I noted the length. I delayed the rest of the length of the cycle. Then I printed the angle, and finally the control. So, questions? I think not. Oh, we have 10 seconds. 1, 2, 3, 4, 5, 6. Oh, you think I'm going to go over it? Nope.